How many pieces are there on a 3x3? Most people know the answer to this, and it's 20. And if you include the centers, it's 26. But how about the 7x7? Do you know how many pieces are on here? And what about all these other guys? In this video, we're going to calculate how many pieces there are on a bunch of different n by n's and generate some formulas. This video is the first in a 2-part series, and in the next part, we're going to go even further than the 7x7, and we're going to see how big these numbers can get and just look at the numbers a lot. So make sure you don't miss that. So on any n by n, there are 3 types of pieces: corners, edges, and centers. So let's start off with the corners. 8. If you check on every single n by n puzzle, there will always be 8 corners. So we got that part out of the way. So for the 2x2, we're actually done because that's all a 2x2 is, just corners. So now we're going to calculate the edges. Here's a 3x3 and a 4x4. Now let's take this white-green edge on a 3x3. As you can see, there's only one white-green edge, but on a 4x4, there's 2. Now before anyone gets mad at me, I know that the not middle edges are called wings, but we'll call them edges because it's just easier. But the thing is, we can say the same for any edge, so white-orange, white-blue, white-red, green-red, and all the other edge combinations. Now let's look at the 5x5. We have 1 white-green here, but 3 white-greens. For the 6x6, we have 4 white greens. And for the 7x7, we have 5 white greens. Can you see a little pattern? So basically, CS means cube size. So a 3 would correlate to a 3x3, a 4 would go to a 4x4, and so on. And the edges mean how many white, green, or pretty much any coloring of edges. So this 1 means that there is 1 white, green on a 3x3. This 2 means that there's 2 white greens on a 4x4. As you can see, all we need to do is just take the cube size, subtract 2, and we get the amount of white green edges or any edges. So we can take cube size, let's say 7, and we'll subtract 2, so we get 5. And as you can see, there are 5 white green edges. But of course, white green isn't the only edge pairing on the Rubik's Cube. We also have white red, white blue, white orange, and all these other ones. We actually have 12 of these, in this case on the 4x4, pairs of 2. On the 5x5, we would have 12 of these, like 3. On the 6x6, we would have 12 of the 4 edges. And on 7x7, we would have 12 of the 5 edges. So this is where we get our first formula. The amount of edges on an n by n is equal to the cube size minus 2 times 12. So let's test it out on a 4x4. We can take cube size, which is 4. Then the formula tells us to subtract 2 multiplied by 12. So 4 minus 2, we always do the stuff in the brackets first. That's 2 times 12 is 24 edges on the 4x4. And if you do want to count them up, there are indeed 24. Let's do it on the 5x5. So for the 5x5, the cube size is obviously 5. 5 minus 2 is 3. So multiply that 12, and we get 36. 36 edges on the 5x5. Now I could do the 6 and 7, but since we've got the formula here, you can work that out for yourself. Now let's move on to the centers. So here's the 3x3, or I should really say 3x3x3. And as you can see, it has little 1x1 centers on all 6 sides. Here's the 4x4, and it has little 2x2 centers on all the 6 sides. So we have a 2x2 center here, and here and here. Here's the 5x5, and we have a 3x3 grid of centers on all the 6 sides. I won't go through the rest, but if you go further, then you can see we've got a 4x4 and a 5x5, and a 6 and 7 respectively. So as you can see, we've kind of got the same pattern as last time. You take your cube size and you subtract 2, and that gives you the size of the center on the one side. So what I mean by this is when you take the cube size, let's take a 5x5, so cube size is 5, then you subtract 2 to get 3. So that means you will see 3x3 centers on each side. But as you can see, we don't have just 3 centers, we have 3x3 centers. So what you can do is literally 3 times 3, and that gives you the amount of centers on one side. Now before we go on, I just need to introduce a bit of notation. A number with a little 2 on the top, this 2 means to square the number. So 1 squared is 1 times 1, 2 squared is 2 times 2, and 3 squared is 3 times 3. So to get the amount of centers on one side, all we need to do is take like this side. So we have the 5, the cube size, and then subtract 2 is 3. So we have the 3 here, so to get it on just the one side, all we need to do is multiply it by itself or square it, because it's 3 times 3. So for the 5 by 5, that would give us 9 centers on one side. But of course, these puzzles do not have one side, they have 6 sides. So what we need to do is multiply the number by 6 to include all the other 5 sides. So this is where we get our formula. Take the cube shape, subtract 2, square it, and multiply it by 6. So let's test it on the 4 by 4. So the cube size is 4. Then we'll just do the formula. So do the stuff inside the brackets first. 4 minus 2 is 2. So we get 2 squared times 6. 2 squared, or 2 times 2, is 4. So 4 times 6 is 24. 24 centers on the 4 by 4. Let's try it on the 5 by 5. So the cube size is 5. We'll just write out everything, but we'll replace CS with 5. 5 minus 2 is 3. So we have 3 squared minus 6. 3 squared, or 3 times 3, is 9. So 9 times 6 is 54. 54 centers on the 5 by 5. Now you could just leave it there, but I do need to address one more thing. For odd-laid cubes, they have a middle center, like a very middle center. So on the 3 by 3, it's here, on the 5 by 5, it's here, and on the 7 by 7, it's here. They stay fixed to the core and basically don't move. And some people would not count those as real pieces. So if you're one of those people, then what you need to do is when you start with an odd-laid cube, you subtract 6 at the end, and that gets rid of the 6 centers around the cube. Okay, so what we could do is we could just add all of these up. So this is the formula for edges, this is the formula for centers, and this is the formula for corners. So if you add them all up, you get the number of pieces, and obviously subtract 6 for centers if you want to. But prepare for a plot twist. There's an even easier way to calculate all the pieces on a Rubik's Cube. Let's try it on the 4 by 4. So I should probably mention this little 3 right here, it means to cube the number. So 1 cubed is equal to 1 times 1 times 1. So it's kind of like squaring, but you like do it again. So 2 cubed is 2 times 2 times 2. 3 cubed is 3 times 3 times 3. Pretty simple. So anyway, we have CS cubed, so that's 4 cubed because the cube size is 4. And then we have CS 4 minus 2 cubed, and that is equal to 2 cubed because 4 minus 2 is 2. So now we have 4 cubed minus 2 cubed, so 4 cubed happens to be 64. 2 cubed happens to be 8. So 64 minus 8 is 56. And that is the amount of pieces on the 4 by 4. I was going to explain why the formula works, but if I kept that in, this video would get way too long and a lot of you will get bored. In case you do want to see the explanation though, there's a link in the description and pinned comment. It's a video on my second channel, basically just unused footage from this video. Just a warning, it is a little confusing, so if you don't understand it then feel free to leave a comment on that video or this video. So if it was that easy to calculate, then why did I bother showing you all the centers and edges and corners and stuff? Well, still, it can be useful to know how many centers there are. For example, if you do 5 blind, then you will need to know how many centers there are on the 5 by 5 and how many edges and stuff. Also, if you're designing a cube, particularly a big one, then you'll need to know how many centers and edges to put. And also, it's just cool to know. So that's part 1. In part 2, we're going to look at the numbers a lot more. We're also going to see how the centers compare to the edges. Do the centers get bigger? Do the edges get bigger? How much does it go up by? And most excitingly, we're going to go further than a 7 by 7. We might even calculate stuff like 1,000 by 1,000. Alright, thanks for watching. If you have any questions, because on a video with a lot of numbers, there's bound to be some, especially formulas. Alright, thanks for watching, and I'll see you next time.